Hey, this is Zane from 6627X, and today I'll be teaching you how to design a chassis for VEX Robotics using SOLIDWORKS CAD software. So first, you'll want to go to the resources page of this website and download the CAD library, which has all the VEX parts that you'll need. So if you click on this link, it'll take you here. Then you click on this source code and unzip the folder after you download it into your files, and then you'll have access to every part you need, as well as there are a few missing parts actually, the 2-inch Omni wheel and some of the new pneumatics, which you can download right here. The other important thing you need is a SOLIDWORKS license, so if you don't already have one, you can use this link right over here, and this is a special SOLIDWORKS sponsorship that you can use for competitive robotics and EV teams. So what you do is you fill out your personal information, you fill out the challenge you're competing in, and you basically upload a picture of the machine you're building, and you can get enough SOLIDWORKS licenses for your entire team. After you've completed these two steps, the next thing you need to do is open SOLIDWORKS. Now, once you have SOLIDWORKS open, this window will pop up. If it doesn't, you can also go over here, but you want to go to New, and then create a new assembly. Assemblies are basically collections of parts that you can connect together, and so we're going to be making a chassis real quick. So to start, we'll go to the main folder, we'll go to Structure, and C Channel. And this folder, you can see I actually have it pinned over here. I would recommend doing that as well because you'll be using it a lot, but you'll select the C channel, and you can see it starts as an 8 long, and that's because of this number right over here. So you can select exactly how long you want your C channel to be. So for the purpose of this video, we'll be selecting 28 long because that's how long we want our chassis. You can see the C channel is now 28 holes. And we actually want the flanges pointed towards us for this video, so we'll rotate it like this, and once again like that, and that's exactly how we want it. So now what we'll do is we'll press the check mark so that the C channel inserts itself at the origin and it doesn't move around at all. Looks good. And now we'll insert 2 more C channels. These ones we can kind of just place elsewhere. We don't want them to be fixed. We want to be able to move them around. So this will be the inside C channel of our drivetrain, and this will be the cross brace. And then next we're going to add in our wheels and gears. We'll need 1 copy of each. So we'll go to Motion, Gears, we'll want a 36-tooth gear, and we will want a 48-tooth high-strength gear. So we'll go to high-strength gears, 48-tooth, and insert that. And then lastly, we'll want our wheel. So that is a 2.75-inch anti-static Omni wheel. Perfect. So now what we can do is we can start connecting all of our parts together. So what we're going to want to do is first connect our wheel and gear. So we'll go to Mate. And mates are basically the ways that you connect everything together. So there's all of these different types of mates. There's coincident, parallel, perpendicular, tangent, and concentric. So we'll start with a concentric mate. We select the outside circle of this gear, and then another part of the circle on this wheel. And you can see we select concentric. That means these circles will basically align themselves with each other. We can press OK. And so you can see we can still move this part in and out, but they're circularly aligned with each other. And then the next thing we want to do is you want to space this gear off of this wheel. So we'll select right there, the face of the gear, and the face of the wheel. And so automatically it does a coincident mate, which just brings those things flush up against each other. But we want to select this option right over here. It's called distance. And then we can input the distance we want. We want 0.25, quarter inch, and then OK. And that's good for us. And then now what we'll do is we'll connect this wheel into here. So we want to leave enough space just for a standoff right over there. So you can see the wheel will go right here. So let's select this edge of the C channel. And what's nice about this library is it has these circular edges as well, so you can make them concentric with things. We'll press Mate, and then we'll select the wheel. And you can see it automatically went to a concentric mate. Sometimes you can select it, sometimes it just does it for you. And then now what we'll do is we will actually insert our cross brace so that we can start inserting everything else with spacing. So our cross brace is going to go, you can see our 36-tooth gear goes right about here. So let's attach that. Concentric, and just like that. So now that we have that, we'll insert our cross brace. We'll select this edge of the C channel. You know the drill, concentric, and select this edge of that. There we go. And then what we want to do now is we can see how we can still move this around. So we want to make it fully immovable. So we'll select this edge right over here, and we're actually going to go to parallel. make that parallel with that. And then we're gonna space this off a little bit, so we'll go to that, select that face of the C channel, select this face of the C channel, and then press distance, and we'll do 0.375, 3/8 of an inch. And just like that, we have our cross brace in, and now we'll put the inside C channel in. So you can see it's in the 1, 2, 3, 4, 5, 6, 7, and 8th holes. So we'll select this, the 7th hole, and then we'll select this edge right over here, and we'll go make this one parallel as well. And what we can actually do is, it's undefined in this axis, we can select this face, and it'll bring them to the same plane if you make them coincident, and then now this is good. The way that you know that a component is fully finished is you can't drag it around, and it'll bring up this little dialog box that it's fully defined. And so actually, for our wheel and gear, they are not fully defined at the moment. You can still drag them back and forth, so what we'll do is we'll select our gear face, press mate, select this, and we're going to do another distance mate. So we'll go 0.1875, so that's an 1/8 of an inch and a 1/16 of an inch. And then we'll take this gear face, not that. And if you ever select the wrong edge, what you can do is you can right click, and you can press clear selections. You can press that face and that face, bring them aligned with each other, and there you go. Alright, and then the next thing we'll do is we'll start putting in all the screws, bearing flats, and spacers we need, and then we're basically going to make one part of this drivetrain and then pattern it all the way along the rest of the drivetrain. So I'll show you what that means in a second, but we'll start by going to hardware, we'll go to screws and nuts, and we'll go for a 2.25 inch screw. And this will be going all the way through the wheel, so let's select this face, and we can actually make this concentric with the wheel. So we'll go right there. You can see it's facing the right direction, and then we'll go press this face and this face of the screw, and there we go. And now the next thing we'll do is we'll put the standoff that goes across our drivetrain from there to there. So we'll go insert components. We'll start by putting in the screws. We want a 0.25 inch screw and a 0.625 inch screw. And then we'll want in terms of standoffs, we'll want a 1.5 inch standoff and a 3/8 inch spacer. And we'll want that one to be one of the lower profile spacers, so the 0.375 inch diameter. Go right there. And now we'll mate all of this together, so we'll go mate, concentric, and then we'll mate this face to the back face of the spacer, and then we'll do the same idea with this standoff. Oh, not that one. Mate those together, and then we'll mate the screws in just so it looks nice and polished. And screws are not always necessary, but I generally like to put them in, especially if you use CAD for notebook purposes. Makes everything look a lot more professional. And additionally, the purpose of CAD is to help you in building, so if you put screws in, it just helps you kind of plan everything out, and if you take a picture of your CAD, you can pretty much just copy it. And then here you'll see we ran into an issue. So I mated this concentric, but you can see the screws facing the wrong way. And to resolve that, what you can do is you can press reverse flip mate alignment, and you can see the screw will be reversed and facing the other way, which is actually what we want. That's kind of stuck in there, so I'm gonna oopsie daisies. We'll clear selections. We'll just drag the screw out. So you want to select one of its faces and just drag it out, and then we'll select there and there and mate them, and then we're good. And then the other thing we'll do is we'll put the shaft that goes in there, and we'll put the spacers that go in the cross brace, and we will start inserting our motors. So let's start with that shaft. So we're going to go to insert components, and we'll actually start with the bearing flat for the shaft because that's very important. We'll go to retainers, actually. You'll see why afterwards. We'll go to the one post hex nut retainer with the bearing flat, the first one, and then we'll go mate this concentrically with this hole where the gear is. You can see it's facing the right way, and then we'll go pull it out for a second. We'll actually want to make it straight, so we'll go select that edge, made it parallel with that, and then there we go. You can see it looks nice, and then we'll actually just put the screw in there for convenience. Go back to hardware, screws and nuts, and we'll go 0.5 inch screw. So let's select that face, made it, there we go. And then we do want it to actually face on the inside, so we'll select that face, and we want the screw to face out with the head on the inside. And there we go, looks nice. And then the next thing we'll do is we'll put our shaft in there, so we'll go insert components, capped shafts, we're going to go for the 2.5 inch one. Insert, and we'll make concentrically with the outside edge, so this edge we made concentric, and then we will make that flush with the face of the shaft right over there. And you can see the shaft sticks out a decent amount, and that would be enough for a motor. And so the next thing we're going to do is we'll put the spacers and screws into our cross brace. So we'll need, we'll start with 2 spacers, 2 3/8 inch spacers. That's how much I spaced it off before, if you remember. And then we'll get 2 screws. We'll get a 1.5 inch screw, and you'll see why it's so long in a second. And we'll get a 0.625 inch screw. Excellent. So we'll start by mating the spacers. We'll go mate, concentric, and we'll mate the faces together. And then we'll do the same thing with this one right over here. Just align it nicely. And then now we'll put our screw in. So if we'll start with the shorter one, and the shorter one is the one that goes above the bearing flat. We'll flip mate alignment, and then you can see it's kind of stuck in there, so we'll just drag it out before we mate anything. And just in case I haven't made it clear so far, the way that I'm kind of adjusting around the screen, if I hold the middle click button on my mouse, I can rotate all the way around, and so I can look at different angles of the robot if I need. And if I hold the right click button on my mouse, I can rotate parts around, which is really useful. And alternatively, you can also go to this window right over here, which allows you to just select different views. So you can go, let's say, to like an isometric view, isometric from the other side, for example. So now just to continue, we'll mate our screw, concentric, select that face. Oh, I actually need to drag that out a little bit. And you can see the screw goes all the way through, and this is why we use the retainer, so that the screw can fit in there. And what this allows you to do is box your C-channel. So you would put a caps nut right there and a caps nut right there, and your whole mechanism would be a lot stronger. Okay, great. So now the next thing we're going to do is we're going to start patterning everything out. So we'll start with our wheel, and then we'll go to linear component pattern. We'll select the direction, so which way we want it to go. We want it to go along the C-channel. You can see this arrow is pointed the right way because we want to go that way. We'll select 4 instances. That's what this refers to. And then this is the distance in between instances. We'll select 3.5. And then you go to components to pattern, and we want to select our wheel, our gear, and the screw for our wheel. And you can see this is just a preview of where everything will go. If we press OK, it just took it and copied it 3 times along the C-channel. And now the next thing we'll do is we'll do a similar idea just for the gear, actually. So we'll go to 3 instances because there's only 3 gears. We'll go to the same direction, and then you can see components to pattern. It selected our past pattern. We'll actually clear that, and we'll select this gear, the shaft, the hex nut retainer, and the screw. Awesome. And so now what we'll do is we'll start inserting our motors. So to do that, we'll go back to insert components, and I like to do the motors actually individually as opposed to with a pattern. And I think I misspoke before, these cap shafts are actually a bit too short for the motor, but they're just what we have conveniently on hand. In real life, you'd probably want to use a 3-inch long shaft, which you can just kind of figure out by putting it in there and seeing if it goes into the motor. So you see, I selected this far outside edge of the motor that's 2 holes away from that, from the axle. So we'll go that edge and this edge, and we'll go concentric. It already selected it for us. We'll drag this out a little bit so it's convenient. And then we'll select this face and the face of the motor so that they get flush with each other. And then the last step is we want to do a parallel mate. So we'll select this edge, go to parallel. Any C-channel edge would work, and you can see there we go. Now this motor is aligned. The axle is into the hole of the motor. And then we have 2 more motors to insert, so we'll just get both of those in here. And we'll have these 2 motors right flush up next to each other, so we'll go rotate them right there. We'll select this edge. Oh, not that one. Mate. Select this edge. Not that edge. Selected a face by mistake. Concentric. And I'm actually using a mouse right now. It's definitely what I would recommend for the easiest way to do it. But you could definitely use like a trackpad or something. It's just with the mouse you have all these nice shortcuts. Then we'll made it like that. There we go. You see that motor is nice and good, and we'll make this one pretty much the same way. And feel free to speed me up. I'm going a little bit slowly for the benefit of people who've never done CAD before, but you can obviously skip ahead if you finish quickly. Alright, and there we have it. We've got our motors in there. Now the next thing we need to do is our cross brace and the standoff on that side. That's the last 2 things we're missing. So we'll start with another linear component pattern. Or actually what we'll do first is we have to insert these last 2 screws on the inside. So we'll go back to hardware, screws and nuts. We'll go to 1.5-inch screw and a 0.625-inch screw. And so basically the reason why we can't just copy this over is this boxed hole would interfere with the motor. So what we want the boxed one to be is actually in this row of holes rather than in this one. So we'll just add that in real quick. We'll go just like that. Oh, I actually put that in the wrong hole. Here, let's just finish this mate real quick, and then we can fix that. So we'll start there, there, concentric, reverse it. The screw kind of got lost in there, so we'll pull it out a little bit. There we go. Okay, and so you can see we actually put this screw, we concentrically mated it to the wrong hole. So what we'll do is we can go select this screw. You can see it'll show up. Open it, press this little drop down the mates, and then we'll right click the concentric mate and edit it. And so you can see it pulls up these 2 edges that we had. We knew that the C-channel edge is wrong, so we'll delete that and select the correct one. And there we go, we're good. And then actually what we'll do is we'll just pattern over these 2 spacers. So we'll go here, it's a 2.5-inch distance, 2 instances, components to pattern, just spacer, spacer, oh. So you can see it's actually pulling it out the wrong way. We want to go inward, so we'll press the reverse direction button, and that just makes it pattern the opposite direction, which is nice. They're exactly where we want them. And then I'm just going to pattern everything over even if the screws aren't perfectly in the right holes, you'll definitely be able to put them in the right ones when you actually build the mechanism. So just for sake of time, we'll go to linear component pattern, select the direction, and if you'll remember before, what we did for the wheels was 3.5 inches. So if we want to go kind of twice that, we want to go all the way over here, it'll be 7 inches. 7, and then we'll select our cross brace, screws, and spacers as well. I want to pattern everything over so it looks nice. And then we can press the check mark. And look at that, the cross brace looks all nice. And then we just need, the last thing is the standoff, so we'll go back to linear component pattern, clear that. We want to select the standoff, spacer, screw, and oopsie daisies, other screw. And then we'll go, it's actually 13.5. If you remember, each hole in a C-channel is half an inch, so if we're starting and we want to go 27 holes away, 27 times half an inch is 13.5. And then we need to go to direction. There, exactly right where we want it. Cool, and so now we have exactly half of our chassis done, and conveniently, you don't actually have to redo this entire process for the other side of the chassis. What you can do is it's called mirroring it. You just basically copy it around an axis. And so we'll go to mirror components. And so you'll see the first thing you need is what's called a mirror plane, and that's what you're going to mirror it about. And so SOLIDWORKS comes equipped with 3 planes. The front plane, which is right there on the outside, the right plane, which is like, the top plane, which is like on top, and the right plane, which is kind of parallel to our cross braces. We want a plane that's basically right here in the middle, and so we can actually make our own plane. So we'll go to reference geometry, go to plane, and so first reference is basically we just want to choose a plane that we want to reference it off of. So we'll basically just say this one, and this is like, so that has a reference for the X, Y, and Z axis. And then what we'll do is it's going the wrong way, so we'll flip offset, and then we want it to be right in the middle. So if you'll remember, our width is 28 holes. 28 times 0.5 is 14 inches. So the whole robot is 14 inches wide. We want half that, so we'll go 7 inches. And you can see if we go, this is making sure that we have a perfect side view. I just did that by, again, going right over here and pressing, it's called the left view. So you can see we have 1, 2, 3, 13, 14 holes, and then our plane is right in between the 14th and 15th hole, so there's another 14 on this side, and that means it's perfectly in the middle, so that's good. And then we'll go, we still have the plane selected if you look down here, so we'll go from there and we'll go to mirror components. And you can see mirror plane, our plane is selected. Now components to mirror, we want to select everything that we've been working on. So the easiest way to do that is to just go click this one, hold shift, and then click all the way down, and that'll select everything. We don't actually want everything to be selected, so we'll deselect that. And then you can see all the things we patterned. So the wheels, the gears, and a lot of these spacers are not selected, so we'll have to go to local pattern 1. You can see if you just like hold your mouse over it, it'll highlight about what your pattern was patterning. So for us, that would be the wheels. We'll select that. We'll select local pattern 2. That's our 36 tooth gears. Local pattern 3, that was these spacers. Local pattern 4, that was the rest of the spacers and the screws. Local pattern 5, that was the standoff. And then we actually don't want this C channel, that was part of one of our patterns, so we'll deselect it. Oh, that's not right. We'll actually just deselect this whole pattern. And what we'll do instead is just select each of these components individually as opposed to selecting the whole pattern, so skipping number 4. You can see I'm making sure to select every screw and every spacer. Now, you can tell we have everything except for our 2 cross braces selected to mirror, which is exactly what we want. Then we'll press the check mark. It might take a second. Oh, brother. That's not right, is it? Let's go back to mirror plane, edit feature. Oh, so it looks like we have the wrong plane. We must have selected it by accident. So we'll go back, you press this little caret on the drop down menu, go to our plane, press OK. Oh, and actually it double selected that C channel somehow, so we'll just go back and deselect it real quick. But if you can take a look, this is pretty much how we want it. So you can see now everything is perfectly mirrored to the other side. Both sides are copies of each other. And yeah, that's basically how you make a nice looking VEX chassis. This is 450 RPM on 3.25-inch wheels with a 4-hole gap. It's 28 holes long by 28 holes wide. You can box it in 1, 2, 3, 4, 5, 6, 7, 8 holes. And yeah, that's it for the first video of the series. Before you exit out, you want to put everything into a folder. So you want to click on the top one, hold shift, click on the bottom one, then right click, add to new folder. We'll call it chassis. And this just makes it a lot more organized, which is really important because once you get to bigger robots, like for example, this is like an older prototype of a high stakes robot. You can see I have chassis, intake, mogo, meg, electronics, and this makes it a lot more organized instead of just having like a trillion parts everywhere. And then you can't actually put patterns into these types of folders, so you kind of just have to put them in their own. That's why mine's all the way down here. But it's the same process. You would just go here, click all the way down, right click, and call it like chassis patterns or something like that. There you go, nice and organized. And then just save it, rebuild and save. And then I'll call it 450 RPM or 450 2.75 inch. And so what I did actually was I went in here and I created a new folder. So I went right click, new folder, and I called it bots. So that's where I saved my robot and different drivetrains that I have. So I'll just save it like that. And then you're good.